Today, we're diving into something critical: how to build AI that doesn't just work, but can actually handle the chaos of the real world.
And it all starts with a story. So, gather round. Story, once upon a time.
There was this massive AI system, right? And it failed all because of one tiny typo. And because it had absolutely no memory, it just kept making the same mistake over and over and over again.
Until the server bill hit the thousands. Seriously, thousands of dollars wasted, all from one little error. Now, this isn't some fairy tale. It's a real-world nightmare for developers. So level up, study buddy. Let's build something better.
This brings us to what I like to call the stability wall. It's that moment when your brilliant AI prototype, the one that works perfectly on your machine, just hits the real world and completely falls apart. So why does this happen?
Well, the heart of the problem is something called fault tolerance, or, the lack of it. See, as your AI systems get more complex, this becomes your single biggest challenge. It's really the difference between a cool little toy and a production-ready tool.
Let me give you an analogy. Think of a simple AI agent as a fragile chain. If just one link breaks, boom, the whole thing is useless. But a truly resilient system? That's more like a web. If one thread snaps, the structure still holds, and you can just find another path to get the job done.
And here's the crucial point. Without the right architecture, any little error means you're back to square one. You have to restart from zero every single time. And to make it even worse, as the AI tries to remember the entire conversation, we call this full context, it gets so slow. The token costs just skyrocket. You're literally paying for every word it has to reread again and again. It's just not sustainable at all.
So how do we smash through that stability wall? Well, we give our agents superpowers. Let's get into how you can architect an agent that is, for all intents and purposes, unbreakable. Now, the secret isn't a bigger model or more computing power. Nope, it's a really simple, elegant idea: statefulness. This is just the system's ability to remember its progress and maintain context from one interaction to the next. Our first superpower comes from an amazing tool called LangGraph. Instead of that simple, fragile chain, it builds your workflows as graphs. And because it's state-based, it uses what are called checkpoints to save its progress along the way. This is huge because it opens the door for error recovery and even, get this, time travel back to previous steps. Okay, so here's how that time travel actually works. The agent's humming along and suddenly hits an error. Instead of just crashing and burning, the system says, whoa, hold on, rewinds to the last safe checkpoint, tries a different path forward, and carries on to success. It's basically self-healing. How cool is that? LangGraph's stateful approach is absolutely perfect for those complex, long-running tasks. But there's another way to scale: swarms. Now these are stateless. They have no memory of past interactions, and they're completely modular. Think of them like a team of specialists. Each little agent does one small thing perfectly and then passes the baton. This allows for massive parallel work without one central point of failure. Okay, so we've tackled the failure problem. That's awesome. But what about that crazy lag we talked about? The one caused by the AI trying to reread its entire life story every single time you talk to it? Well, say hello to our next superpower, MEM. This is a brilliant, scalable memory tool. Instead of force-feeding the AI the entire conversation history, Memo intelligently goes in and retrieves only the most relevant, the most salient information for the task at hand. It's like having a smart assistant who hands you the exact paragraph you need from a book instead of making you read the whole library. And the results? They're just staggering. Just look at this chart. With full context, the latency, that lag, it just keeps climbing and climbing. But with Memo, performance stays lightning fast and super stable, no matter how long the conversation gets. This is a total game changer for the user experience. All right, so we've got the individual tools, the superpowers. Now let's put it all together into a real blueprint for your own production-ready digital workforce. So to build a system that basically never quits, you need three key things. First, a reliable orchestration layer like LangGraph to manage the whole workflow. Second, built-in persistence to save the state using those checkpoints. And third, you need a human-in-the-loop capability, so you always have that explicit control to step in whenever you need to. Okay, time to put what you've learned into practice. I've got a quick mission for you. Ready? Think fast. What's the key feature that lets an agent pick up right where it left off after hitting an error? That's right, it's state management, using those all-important checkpoints.
That is the fundamental concept that makes all of this incredible resilience possible.
Now for the real question. I want you to think of a big project, something that takes you hours to finish. If your AI assistant tripped halfway through, would you really want it to restart all the way from the beginning, or just resume from its last checkpoint? The answer's pretty obvious, isn't it? That's the power we're talking about building.
So look, if you take just one thing away today, let it be this. A stateful architecture isn't a fragile chain. It's a multi-path web where you can jump back to a safe spot and try a different route without ever having to start all over again. Hey, if this helped you level up, make sure to like, share, and subscribe to Study Buddy with Notebook LM. It's your daily guide to building a production-ready digital workforce.
Stay ageric.